Sorry about this. All right, so our project was an AI change counter. So basically what we would do is we would take a picture of a bunch of coins on a flat surface, and then our AI would tell what the coins are and count their total, and then convert them to whatever currency you would like them to be put into. Next slide. This is just our agenda for this slide. Go to the next slide. All right, so we made this AI for a certain for a number of reasons. First is that oftentimes you have a lot of coins and you really don't have anything you can't really use them because they're too heavy and they're too and they have too little value, and oftentimes they end up in jars like this. These are coin jars, and they become a dead weight on the economy, and thus are not being circulated anymore. And this is not really what money is all about. There are some machines that do take coins, like Coinstar, but they take 11.9% of your change, which obviously adds up if you have a lot of coins and you're trying to convert all of them to a higher valued currency. So this is not really the purpose of money. Money is supposed to be universal. That's why we invented money. We invented money to avoid this coincidence of wants, where you could only make a trade with someone if you had something that the other person wanted, and vice versa. And this was very rare. So having a medium of exchange where everyone wanted it would help would actually make transactions possible. And so we want people to save their change in order to make a positive impact on the economy, and we want faster checkouts at stores. You've all heard of the story of the grandma who's too busy, like with her pennies and trying to pay for a $1 loaf of bread with 100 pennies. But cashiers don't really like this, so we want a way for people who handle coins to count them quickly and move on with their day, because at the end of the day, the more you spend, the more the economy benefits. The faster a transaction is able to be made. And so we are um, um, detecting all American coinage and also the Canadian penny, a nickel, dime, quarter, and for those of you who are not Canadian, the loonie is a $1 coin, and the toonie is a $2 coin. Next slide.
Okay, so some of the challenges that we had to overcome. So since we were in the topic of computer vision and we had to train our model through machine learning to be able to recognize an image, we first of all had to obtain images. So at least during our time, we had a bit of trouble getting some images from like RoboFlow, Universe, and just regular data sets that you can find on Kaggle. So what we did is one of our teammates found an image extractor online that would take the link of a web page and convert all the images on a web page into a data set. So for example, if you're on Google Images and you copy that URL into this certain website that would extract the images, then we could use that in our data set. And then from that, we were able to obtain thousands of images. And the next challenge that we had to overcome was our website design. So a lot of us were new to HTML and CSS, and while we wanted to have as much knowledge as possible on HTML and CSS, we had to limit that with what we could create with our website and what features we wanted. So what we did was we use sources like GitHub, We3Schools, I believe is what it's called, and Stack Overflow. And they would usually provide source code to the different features that we wanted to incorporate. And from that, we would learn and modify those for our website.
So in training our models, we decided that it should include both US and Canadian coinage, and that when you take a picture of the coins, it should be flat out and none obstructing each other. And when we exported our data set to train the model, we decided to rotate the coins and make them different brightnesses and saturation in order to mimic a detection in the real world. Next slide. In our training from one of our models, you can see these loss, this train loss and object loss and class loss. At optimal training would be kind of this exponential decrease. And you see with this model that is clearly shown. And as our model trains, our mean average precision also increases. Next slide. From our models, the confusion matrix demonstrates how the true class versus the predicted class. In its training, we can see that, for example, the Canadian dime has only a 0.6 confidence and is often confused with the background. But other than the Canadian dime and the Canadian loonie, and maybe the half dollar, all the other ones are above 80% and doing very well.
Okay, so now we'll move on to our website. These were kind of some of the templates that we made on Figma. But yeah, I think there's one more. Yeah. So these were just templates that we made for our website.
So I'm gonna show a demonstration of our site. One thing is we didn't actually use any like CSS templates, so we made all of this from scratch. So just going onto the homepage, you can see we really wanted it to be like something utilitarian. So the moment you get on there, it becomes like usable, and you're greeted with a big friendly prompt to either drag and drop or browse file. Personally, I use a Mac, and I feel like you can drag and drop on everything. So I really want to make sure we could do that for the website. And so later I'll show you the JS file, but yeah, let's see, once you hover over it, it lets you know that it's active and it starts processing. So there's an animation while you wait just to make sure that you know that it's going on, and then you're greeted with the results. So this is what YOLO v5 object detection algorithm shows you with all the bounding boxes for the different images. And you can see that, yeah, it looks pretty good. I'm actually Canadian myself, so I wouldn't be able to exactly identify all of these, but yeah, you can see the quarters, they are a bit larger, the dime's a little smaller, and the penny obviously is from copper bronze. And then you also get the breakdown of the coins on the side. And the reason we have this toggle over here is sometimes when you have change, you might have been visiting different countries or you have different denominations. And so you might have some miscellaneous other currencies. For example, all of these photos, by the way, are from Julian's coin jar that he was showing earlier. So this photo has a Canadian loonie at the top, whereas the rest of the image is all US currency. And you can see our algorithm actually picks up on it. And in the end, you can sum it up to one desired currency at the current exchange rates, which we used a Python library currency converter for. And you can do this infinitely to your own pleasure with our new image, and you can just keep resetting and going. Our code is available on GitHub, linked over here. And we also linked the AI campsite in the footer. Just talking over a little bit of how we made it. I'm going to hand it over to Vincent to talk about the backend.
On the backend, we use Flask as everyone else did, but the bulk of our work, I would say, is the part where we load our model and we take the image, draw the boxes on it, and we have to extract the class names from there, count how many of each class name there is, and then we sum up the currencies in their own, like some of the coins in their own currencies. So if you have only US coins and we have only Canadian coins, they're going to be in their separate amounts, and then we get whatever the user wants to convert the total amount to, and we convert either both of them to a separate currency or one of them to another. And we again use a Python library for that. Originally, we were using a different Python library, and this, in the span of like 12 hours, the library hosted on GitHub, they updated it and they broke it, so we had to use a different library.
So talking a bit about the front end and the middle end, since we wanted this all to be a seamless experience, we decided that we didn't want to use any like redirects for the site, and we want to keep it all here. And so we used AJAX requests in the JavaScript to handle this. So whether or not you upload this way or you do it by drag and drop, it'll send it and it'll work. And yeah, we also have just a bunch of animations that are meant to make the experience a little easier, like the processing animation, some hovers just to make sure that you know it's a button. And yeah. Now we'll talk about who we are and us as overall as a team.
Okay. Actually, or before we get to that, then this is what we wanted to do with our style CSS, where we wanted to incorporate top images with different opacities, and then also be able to have that you can hover over our images and see our descriptions. So I'll start off. I'm Anika Bahri, and I am from Vista Ridge High School in Austin, Texas, and I assisted in the layout and also designed a lot of the UX and features on the front end. Yeah. Next is Glauk.
Hello, I'm Glauk. I'm from Amarnik High School, and I assisted in the front end.
Next is Jane. They couldn't be here today, but they inspired the idea for this coin counter. They go to Paul Duke STEM High School, which is in Georgia, and they also worked on the front end.
All right, hey, I'm Julian Maynes. I live in Los Angeles, California. I go to Loyola High School, and I worked on the training for all the images, especially all the coins that had different backs and had multiple variations, and I also assisted with the front and back ends.
Hi, I'm Justin Liu. I'm an incoming data science major at UCSD, except I'm actually based in Toronto, Canada. And so when we were discussing originally the currencies that we want to use, we had like a few others that we wanted to get to, but we didn't end up having the time. But I did advocate for having Canadian currency, and yeah, I worked on different parts of like connecting it, like the middle end, and I also designed the layout and implemented all the front end for the count page.
Hi, I'm Vincent. I'm a senior at Columbus High School in Georgia, and the bulk of my work was either training machine learning models or working on the back end. I know, along with like Julian and Justin, we exhausted our GPU hours in CoLab multiple times because we spent like maybe like 2 or 3 hours training our object detection model.
It was hard.
And of course, we were mentored by Ryan Quinn. I believe he's in the call. Yeah, he goes to Northwestern, and he was really helpful throughout the entire project. Shout out to him. And we have one final page just talking about the inspiration, where you can revisit Julian and his coin jar at any time you please. And just because you mentioned it, these were some of like the specialty quarters. We had a bit of an issue, like trouble identifying them before. Actually, right now, all 5 of these do work, and yeah, that's just a testament to Julian as well. That concludes our presentation. Thank you for watching. Does anyone have any questions?